So I'm pretty sure that you guys are all familiar with the three-layered architecture, something that we've been using for the last 15 years, especially within the microservices, right? Representing three different tiers: the client, the server, can be a monolith or can be microservices, and of course a database. Now this paradigm or this architecture has evolved into something else, and I want you to adapt your company's product, or if you have your own product, I want you to update this architecture into something else, because with the rise of AI and AI agents, you should be using this instead. And I'm going to tell you what the differences are, and I'm going to show you the code as well and what an example architecture would look like. So we're going to start with a traditional backend, something that most of us had probably until this year. So a traditional backend or traditional three-layered architecture would look something like this. We have the client, which is the first layer. Obviously, we have the backend, which is the second layer. And here we would usually have an API gateway. And by the way, I have a video on an API gateway for you to learn what exactly it's doing. So in this case, it's doing the authentication, routing, rate limiting, and we would have services like really dedicated services, service A, service B for payments, service C for users. And we would, of course, have the third layer, which is a database, can also be cache. And we would have a message bus if we're doing an event-driven architecture. Okay, one interesting thing here is that we can still do AI with this architecture, and we can do it very well. So let's say we have a dedicated service specifically for AI, and here we're using a framework called TensorFlow Serving, which facilitates serving AI data through a normal backend, and it would be connected to a vector database, right? This would be the classic architecture, probably up until 2023. This is how we would do AI. And this AI service with TensorFlow, it's still commonly used, for example, for recommendation, right? Now, the new AI era backend would look a little bit different. Let me tell you why. So we would have the common things, the client, which is the front end. We would have our API gateway, but now depending on the request that the client makes, we would route it into two different categories. So for the normal CRUD operations, such as the get, put, let's say the orders, the users, we would go to the left side. And here we again have our microservices, let's say bundled all together. We have our database, we have our AI service doing like really classical machine learning, not talking about LLMs at this point. But now our LLMs are living on a different side. And the API gateway that does the authentication and routing, now it routes the intelligent requests, for example, like summarization or object detection on an image or generating something. Let's say you're an e-commerce website and you want to generate product images on the fly, right? You would usually do this with LLMs and generate some text on top of that. And this is why this would be rerouted to an AI gateway. Okay, so AI gateway is the entry point for our intelligent requests. Now, AI gateway is going to implement the token limits. So whatever you need to limit there, something similar to route limiting, you would do the routing, because you would not only have one agent nowadays, you would have multiple agents, and you probably know why this is a better architecture than having one agent that's responsible for everything. You know, same with microservices. The more agents you have, the more specialized they are, the better the output quality is going to be. And of course, we can also do caching at this point. Now, I'm also going to make some interesting videos. For example, how do these agents are actually communicating with each other? What are the patterns for communication? And what are the difficult parts of the agent's runtimes that every senior developer should know? Also, how does the event-driven architecture is even looking like with this AI gateway and agent runtime? I'm going to make videos about this, so if you're interested in these advanced topics, make sure to subscribe and don't forget to smash like at the end of the video if you find this video useful. Now, the AI gateway obviously is going to route the request to an agent runtime. And in this case, it actually can go to any of these agents. So it can go here too. So let's make it like this, right? So the agent runtime is where we are interacting with an LLM. LLM can be hosted on a cloud, on your own machine, but the agent runtime is actually responsible for invoking the LLM, all right? So we're going to do the planning here. We're going to do a custom reasoning. If we're using some kind of an LangChain, LangGraph framework, or ADK from Google, we're going to be doing the orchestration here. And I'm going to make videos on that too, on AI, agent architectures and so on. So make sure to subscribe. And also we're going to have a wrapper, let's say an MCP server, but let's call it a tool layer, because whenever the agent is doing some predictions, it sometimes actually needs to contact our own microservices, right? Because the agent runtime does not need to talk to the database right away. Instead, it can contact the tool layer, and the tool layer then, here's the arrow, it goes and talks to our microservices. Let's say it pulls the data for the last year of the orders of a specific user. And then once the tool layer has this data, it can give it back to the agent runtime, and agent runtime can do some kind of a prediction or a summarization. Now, another cool thing here is that we are also having a vector database, and the vector database is also going to be connected to a tool layer. So as you can see, we are really separating. We're having a 3-layer architecture within our 3-layered architecture, okay? So the API gateway is doing the old classic way of distributing the microservices and the client and the database, and we have another AI gateway. It's not an API gateway, it's an AI gateway, but it works in a similar way. And these are, so to say, our microservices, right? The agents, they're specialized. For example, this agent does summarization, this agent does image generation, and so on. You get the idea. And we have this interesting tool layer, which is basically a wrapper for our microservices or whatever data we need to grab from like a SQL database. And of course, the vector database, where we're going to be saving the contextual data, right? Not like structured data. And of course, not only the microservices can do events, so talk to the message bus, and let's say this message bus gets the message, and then some other microservice can subscribe to this message, but also our agent runtime can also put messages into the message bus. But this is going to be shown in a different video. Now, let's go back to the code. If you didn't understand anything so far, I hope the code will make this more understandable. So we have a simple Node and Python project. As you can see, we have the gateway, and the gateway is responsible for our usual microservices, and the microservices are living within the services folder, as you can see, orders.js and so on. And for now, it just has one endpoint / orders, and it's going to return some hard-coded data. So I'm not even talking to a database here. And we also have our AI gateway, which is also a Node code, but it's going to process the AI request, do some logging, do some token limiting, and eventually it's going to call our Python service. So the Python services are living here. So we have the server, which is basically having one endpoint, agent / run, and it has also has another endpoint, the health endpoint. But the agent / run is going to do the following. It's going to run the agent, and running the agent basically means the following. So we're, of course, doing some session management here, but this is not the most important part. The most important part is actually here. If we're not using the mock, we're going to run this Claude run, and Claude run is doing the following. We have the system prompt, and we're giving it an additional context that we save from the memory or we pull from the memory. And every time we make a call to, or we send a message to Claude to make a prediction, we are going to check whether the answer actually included the word tool use. If we get an answer that includes the tool use, meaning our agent runtime actually wants to talk to the tool layer. And depending on which kind of a tool it wants, we are going to get the tool name and make a request. So how is the tools.py look like? So as you can see, if the tool name is get orders, then we're going to make the request to the /orders. If it's get users, then /users. So you get the idea. And once we exhaust this loop, and once we no longer have a need to talk to a tool, we simply append the messages for the future, and we simply return the answer right here. So if not tool use blocks, so if there's no need to use the tools, simply return the answer. Okay, so you get the idea. This is pretty much how our backend in the new AI era is going to look like. And as I said, I'm going to make videos about these 3 points as well as the event-driven architecture within the new AI era backend. So stay tuned, and I'm going to see you in the next one. Goodbye.